Hello wonderful person, this is Anton, and imagine this. Imagine an event so powerful that if it happened in our galaxy, it would very likely cause another mass extinction. Today we're going to talk about the gamma ray burst that has just recently been detected, and let's also discuss why it's important and what we know about them. Welcome to What the Math. Back in 1960s, the United States launched the satellites known as the Vela satellites. Here's an actual photo of the satellite Vela 5A and satellite Vela 5B, and the only purpose that these satellites had was to actually make sure that the Soviet Union was not conducting any illegal nuclear tests. It was basically a satellite orbiting our planet and then looking down on our planet searching for potential gamma ray bursts. The burst that would very likely be caused by essentially this, a nuclear bomb exploding. And it just so happens that in 1967 the Vela satellite detected something unusual, and it wasn't coming from our planet, it was coming from up there, the universe. And it obviously took a few decades to finally explain what we're observing. And the breakthrough for this came in 1997 when this Italian-Dutch satellite known as BEPO SAX detected and also accurately located the first ever gamma ray burst observation with a lot of accurate measurements. And since then we were able to detect quite a lot of them. As a matter of fact, since then we've detected over 1,000 of them all across the skies, and what we know for a fact is that these events are pretty rare. And we know this because every one of them detected so far has been at a really far away distance away from our galaxy. The closest one to Earth so far has been at a distance of about 130 million light years away from us. That's about 60 times farther away than the Andromeda galaxy to planet Earth. But the fact that these events are so rare is actually good, because scientists today estimate that if one such event happened in our galaxy and also pointed at our planet, it's very likely that this would be the end of life on our planet, or at least it would cause a serious detriment to the atmosphere. But before we go on, so what exactly are these events? Well, in a nutshell, today we believe that a typical gamma ray burst happens inside a very massive star when it suddenly starts collapsing and the black hole on the inside that suddenly forms starts releasing these two astrophysical jets that shoot even through the star itself. And as these jets shoot through the star, they also start hitting other components that used to be around the star, including some of the gas that was released earlier. And through the interaction of the astrophysical jet with the star's material and also with various material nearby, it then starts generating a lot of various frequencies. So first of all, as the material here gets thrown out of the black hole at roughly around 99.999% of the speed of light, it's forced to go through the star, and it's also forced to go through all of these various shells that were formed before the star became unstable and started to experience these effects. The initial burst that you see right here can last anywhere from a few seconds or even milliseconds up to several minutes. And following this initial gamma ray burst, this is when other frequencies start being generated as this really powerful jet starts hitting other medium around the star. So here we'll even have visible light, we'll have radio waves, there will essentially be an entire spectrum of electromagnetic energy that can then be received for a very long time past the gamma ray burst itself. And it just so happens that in 2019 we had a new breakthrough. And this was the observation of the most powerful event to date. It's known as GRB 190114C, and this was a gamma ray burst with the initial energy equivalent to about 1 trillion times more than typical light that we use for seeing things. And here what we're talking about is equivalent to tera electron volts, or according to Wikipedia, basically the kinetic energy of a flying mosquito, but in every single proton, in every single particle. And so this was the most powerful event to date, and also allowed us to see radiation that we've never been able to detect before. And all of this was done thanks to various ground-based telescopes that used their power along with the power of Hubble telescope to combine all of this together and to see what we could never see before. And one of the major milestones coming out of this discovery is, of course, in regards to our understanding of how these 1 tera-electron-volt gamma rays are even formed. The scientists behind this paper believe that it has something to do with the effect known as the inverse Compton scattering. In a nutshell, if we were to look at regular Compton scattering, here the typical high energy light like X-ray light or gamma ray light, when it strikes a charged particle, it will give off some of its energy to the particle, and then the light itself will actually lose some energy. Like, let's just say it used to be X-ray, now it's going to be just regular visible light. But the inverse mechanism refers to the opposite. So if the X-ray light coming off this black hole suddenly strikes the charged particles coming out of this astrophysical jet here, it will dramatically increase the energy of this light. As this energy is transferred to the photons, making them, let's just say they used to be X-ray, now they're going to become these really powerful gamma rays. And what we've detected now, the 1 tera-electron-volt gamma ray, was generated through this inverse Compton scattering, where a lot of energy was added from the charged particles that were generated by these two astrophysical jets. And one of them was obviously pointing at our planet Earth. Now, I'm sure with time we'll discover more about this particular event and we'll even get more data coming out of it, but for now that's really all we know. However, there's one more thing I wanted to mention, and it's in regards to the system known as WR104, the image from which you're looking at right here. This is something we've recorded for many years. Now, WR104 is a Wolf-Rayet star that has a potential to generate such an event, essentially a gamma ray burst. And the other thing about it is that, judging from this image here, it seems to be sort of kind of pointing at our planet Earth. And I've actually made a video about this last year where I've discussed the potential implications of this, and is this basically maybe deadly supernova / gamma ray burst event that might endanger life on Earth? But in reality, the risks of this happening are pretty low. Nevertheless, WR104 is currently the next potential candidate for such an event, for basically a gamma ray burst. Being a ridiculously bright and powerful Wolf-Rayet star, it's essentially at its last ends of days. It might have a few millions or maybe a few 100,000 of years left in it, but for all we know, it might even go supernova a lot sooner than that. And at a distance of about 7,500 light years away from us, it's not that close, but if it's pointing at us with its jet, it could be a potential problem. Now, this is something we'll discuss more once we learn more about these events, but for now, don't panic. It's very likely not going to happen. Anyway, on that note, that's all I wanted to mention in this video. Check out the paper I mentioned in the description below, and subscribe if you still haven't, share this with someone who loves learning about space and sciences, and maybe consider supporting this channel on Patreon. It does help me quite a lot. I'll see you tomorrow, space out, and as always, bye bye.